Hello, this is Mrs. Huntley. We are in Module 7. This is Lesson 3, Existence and Uniqueness of Square Roots and Cube Roots. You should be on page 12 of your module. And your essential question for this lesson is, what is a radical and how do I calculate with radicals? Or how do I solve equations that might have radicals? That's what I mean when I say calculate. All right, we have two charts here. One should look super familiar. If not, check the inside cover of your module and see if you notice anything between our left side and our right side, our left side and our right side. Let's look at the ones that are filled in and see if we can tell anything about them. So let's look here, here, and here. Well, the first one doesn't give us a whole lot of information. But when I look at the left side of the table and the right side of the table, hopefully right now some of you are going, oh, I know this is a square root table. So what I want you to do in a moment is complete the missing sides of this square root table. And if you haven't memorized them and you have to flip to the table that we created on the inside cover of your module, please do that. Please try to resist using your calculator as much as you can. See which ones you know by heart and which ones you still have to work on. So pause the video and see if you can get this table on the left filled out, and then come back and check your work. Okay, hopefully that wasn't too challenging. 2 times 2 is 4. 9 times 9 is 81. 15 times 15 is 225. The square root of 49 is 7. 10 times 10 is 100. 12 times 12 is 121. The square root of 169 is 13. M squared. I wonder, some of you might have been a little confused on how to show that. Just M with the little square sign, or the 2, exponent of 2. The square root of n under the little square root symbol. Finding the rule in part 2 might be a little tiny bit more challenging. Let's take a look at the ones that are filled out again. We've got 3 and 27, 6 and 216. Those are the only two that they gave us. That's going to give us a lot of information here, or give us any information to draw a conclusion on. Because 1, again, it could be anything. Your input's 1, your output's 1. We know it's a multiplication because 1 times 1 is 1. That's when you get your 1 for your input and your output. What could the rule be here, though? Let's think about this. I know it's not a square root table because 3 times 3 is 9, not 27. But what about 3 times 3 times 3? 3 times 3 is 9, times 3 is 27. So this is a cube root table. So this is our input and this is our cubing. So 2 cubed. 2 times 2 is 4. 4 times 2 is 8. What times what would equal 125? So let's think about this. It ends in a 5. So I'm thinking I'm going to start with 5. 5 times 5 is 25. 25 times 5 is indeed 125. So the cube root of 125 is going to be 5. See if you can figure out the rest of the table and then come back and check your work. Pause the video. Alrighty, check your work. 11 times 11 times 11 is 1,331. The cube root of 64, you guys might have been thinking 8, but that would have been the square root. The cube root would be 4. And then 10 times 10 times 10 is going to be 1,000. 7 times 7 times 7 is going to be 343. The cube root of 2,744 is going to be 14. And then how do you show p cubed? It would be p to the 3rd power. And how do you show the cube root of q, or the cubed root of q? That's hard to say. You want to use a cube root sign. Let's take a look. I didn't talk about this before, but a cube root sign is our square root sign with a little 3 in the corner here. That tells us, that's how it differentiates a cube root from a square root. So I would put a q inside that little cubed root symbol. What I would like you to do right now is pause the video and flip to the inside cover of your module and create a cube root table just like your square root table, but only go up to 11. I'm going to show you real quick what it should look like. So our square roots are on the left side, our cube roots are on the right side. Again, we're making our lines, x and then x to the third power, just to help us out. If you want to go past 11, by all means go past 11. You can put as many in there as you want. What I'd like you to do is try to memorize your cube roots up to 10. Memorize your square roots up to 20 and memorize your cube roots up to 10. So go ahead and pause the video, take as much time as you need to create this chart, and then rejoin us as quickly as you can. We have some notes to take and then some problems to solve, and then you're done. Hopefully we'll be done within 15 minutes. Come on. There we go. All right, so some notes to take. How do I solve equations that either have something squared or cubed? When you're solving those equations, you have to undo the power by taking the square root or the cube root, depending on the exponent. Remember, it's super important. Whatever you do on one side of the equation, you've got to do the same thing on the other side of the equation. You can't take a square root on one side of the equation and not the other. It will not, you will no longer have an equation. You'll have something that's an inequality if you do something to one side of the equation but not the other. This symbol is a radical. That's called a radical sign. An equation that contains that symbol is called a radical equation. If there's an n in the corner, if there's some number in the corner, and I'll stick that n up there, that tells you how many times the root is multiplied by itself to equal the number under the sign. If there's no number there, it's assumed that it's a square root. If there's no little number and it's just this symbol, it's assumed to be a square root. If there's a little number, that tells you the degree of the root you're looking for. In our class, we're only going to see square roots and cube roots. When you get into upper level classes, you might see a different number in there, and you might be looking for a number that's multiplied by itself 4 times or 5 times to equal the number under the symbol. But for our purposes, we're just going to deal with squares and cubes. Let's move on. Okay, so on your own, you've got some equations to solve here. X squared equals 169. Those of you that are already memorizing your perfect squares, you might have some bells going off in your head right now. But it says, explain the first step in solving this equation. So being that we haven't done this before, what would our first step be? We're going to take the square root of both sides of the equal sign. I forgot my S here. Of both sides of the equal sign. So when I'm writing this equation, I would have x squared equals 169. In order to solve that, I don't want x squared, I just want x. So I'm going to take the square root there, square root here, and x is going to equal, what does x equal? Square root of 169 is 13. It says check your answer. You're thinking, how do I check my answer? Is 13 times 13 169? Yes. 169 equals 169. It's good. A square-shaped park has an area of 324 feet squared. What are the dimensions of the park? Remember, when we're finding an area, we take the side times the side. A square, our two sides are going to be equal. So we could say side squared equals 324. So we'll say side squared equals 324. We don't want side squared. We want to know the dimensions of the park. Square root, and one side of the park is going to be how long? Check your work. Is 18 times 18 324? Yes, it is. So the park, I guess I should type this. 18 feet by 18 feet. So one side is 18, the other side is 18. Go ahead and solve number 3 on your own. Pause the video and then come back to check your work. Okay, x squared equals 625. Take the square root of both sides, and x is 25. Now we have a cube. A cube has a volume of 27 inches cubed. What is the measure of one of its sides? Hopefully you remember a cube. To find the volume, it's length times width times height, and a cube is going to have all 3 measurements the same. So it'll be side cubed equals 27 inches cubed. Take the cube root, and the side length is going to be 3. You can go ahead and finish 5 and 6 on your own. I want to go ahead and explain number 7 to you. Number 7, find the positive value of x that makes the equation true. X squared equals 256 to the negative 1 power. Remember, when something is to a negative value exponent, it means it's moving to the other side of the fraction bar. So if I have 256 to the negative 1st power, that is equal to 1 over 256. It moves down into the denominator. So how do I find a square root of that? If I've got x squared equals 1 over 256, I take the square root of the left side and the square root of the whole right side. So x is going to equal 1 over 16. See if you can work out 8 and then for 9, and we'll check them in class tomorrow. For 9, it says, is 6 a solution to the equation x squared minus 4 equals 5 times x? So you're substituting in 6 for the x. So is 6 squared minus 4 equal to 5 times 6? 6 squared is 36, minus 4 equals 30. 32 does not equal 30. So therefore, no, 6 is not a solution. When I substitute 6 for x in the equation, the 2 sides do not equal each other. So to conclude this lesson, we know what a radical sign is. We know if we've got this sign alone, whoopsie, where's my marker? If we've got this side alone, it's a square root. If we have this side with a number here, it's a cube root or whatever number is in there. So go ahead and write your summary and make sure that you finish all of these on your own problems on your own, and we'll check them in class tomorrow. Look at this. I'm finishing in 13 minutes. Isn't that awesome? Have a great night. Bye.